This is from Petra in Denmark. Could you please explain from your overview point what happens to the gravitational field of an electron that is in superposition? Or how do you look at this issue when quantum mechanics and gravity cannot be combined?
Well, I can talk to that a little bit. There really are no electrons. When you make up statements like this, it kind of carries a whole lot of assumptions. Like there is such thing as electron, and the electron has mass, and the electron has a charge, and so on. But electrons are really potential. They're a potential thing, and we measure that mass and that charge, and then we make up the model of an electron to say, well, that looks like it's a mass with a charge. So it's as if, it was a mass with a charge. But we know that electrons really aren't that. Reality is just probability until somebody in the virtual reality, needs the data. All that probability just stays probability. When we need the data, then something is sent to us that gives us some results, and that's what we see or hear or smell, or that's what we can see. Now, we can see through microscopes and see through, other devices. We don't have to just see through our eyes or hear through our ears. That includes all of the, lab equipment that we have, but we can sense, we can measure. So that's the quantum physics idea of the measurement problem. Things stay in the form of probability until the measurement's made, until someone in the virtual reality needs that information. The information has to bubble up inside that virtual reality, so it's sent to some player in the virtual reality. Okay, so now we start pretending that electrons are really little chunks of mass. Therefore, they have gravitational fields, and they have electric fields as well because they have charge. And we start working that sort of logic, but yet it's based on something at the very root that isn't true. Electrons aren't little chunks of mass sitting around waiting for us to, create a potential so they'll run through our wire. They don't work like that. Our reality is computed. There are no electrons. There are only things that act as if they were electrons. So the question isn't really a good question, and that's why it gets so confusing in physics. The physicists confuse themselves because they knew at one time that these things were probability, but then they start believing that they actually exist, that there's a world out there that has a bunch of chunks of mass in it that have, gravity. Well, when we're talking about, stars, well, we can see those stars and we can kind of measure and get some sense of whether they're bigger or smaller or far away or close. And there's ways for us to find out some things about those stars. But when they're quantum mechanical like electrons, yeah, we can't do that. They just are probability, and they stay probability until we make measurements. Well, the stars are like that too, but it's just that we can tell more about them. We can kind of say, well, this is 50 times bigger than our sun, you know, and even that's kind of got a lot of error. That's not a very precise thing when astrophysicists say things like that. That has a fair amount of error in it, but still, they can make those kinds of comparisons. But in the very small world where we don't see things, things are just assumed to be there, even though we can't see them or smell them or touch them. But we can see the interaction we get with them. We can see what they do, not what they are. But we begin to believe that what they are is little chunks of mass. And where are all these gravitational fields coming from these little chunks of mass? And how do they enter? It's just not a good question.
There is
There
no
are no electrons.
there is no gravitational field around an electron, is what you're saying too.
Yeah, well, there's no electrons.
There's no
There is no
electrons, so no
gravitation.
gravitational field, no interference. It's a
All
probability. Okay.
those things are computed,
Okay.
and it's computed. From the Newtonian viewpoint, every mass had a gravitational field surrounding it,
Mhm.
and that force of that field was proportional to the product of the masses over the square of the distance between their centers. GMM over R squared, where G's proportionality constant, called the gravitational constant. So in that case, gravitation is created by mass. Okay, now Einstein said, well, that's one viewpoint, but here's another viewpoint that lets us do uh, you know, big, fast things and even small things more accurately. And that's that space is curved, it's stretchy. And the curvature of space time is what creates gravity. It doesn't have anything to do with mass. It's just curvature in space time. Okay. So now that's a different viewpoint. It's a different model. It doesn't mean that's correct. It just means that that's a different model. It's no more correct, I would say, than Newton's, but it applies to more places. It's broader. It's a broader, deeper, what can I say, more successful because it can answer more questions. Newton's was limited. So then we think that Einstein's is better, and that's true, it is better, but that doesn't make it right. It just makes it better.
I'm Tom Campbell. I'm glad you're here. I hope you're enjoying the content. If you do like our content, then you should consider being a Patreon member because Patreon members get early access to our special content. You will also be able to get your questions answered by me in special Q&A sessions just for the Patreon members. And most importantly, your contribution as a patron member will enable us to produce the content that you're looking for. So thank you.
We have to realize that's just a model. It acts as if space-time was stretchy. As if space-time was stretchy. There may be no space-time. That's just a model. But the problem is that people then they make these models. They know they're models. They know it's just an intellectual framework that they have put together to help explain a problem. And pretty soon they begin to believe that it exists. It's not just a model. It's a physical reality. And that's when they make the mistake. So I'd say the question really isn't a good question because there are no electrons. There really isn't any space-time either. It's just those are models that enable us to compute the answers to things that are computed by the rendering engine of this virtual reality. Our reality is a computed reality.
But really, it's a
And
probabilistic reality.
it's probabilistic. Then it's based on those probability distributions, it's computed. And it sends each player gets a data stream. Each player lives in their own reality. You see, so the reality is much more general and actually even easier to understand than is all the when we do all these as ifs and break it into space time that's stretchy and various things. Those are much more difficult to understand. Well, partly that's because we are applying what we call continuous mathematics, things that are computed by a computer. Continuous mathematics don't really describe things that are computed by a computer precisely. One has continuous functions, the other one has digital functions, discrete functions. So there's a lot of things that computers can do that are very difficult to get continuous functions to do.
Well, thank you, Tom. I hope that answers your question, Petra. She just wanted to know what your viewpoint was in what seemed to be a a conflict there. Thank you.